Hey guys, we're going to go ahead and dive on into our Algebra 2 content, and we're going to start here in Module A with Section 2.1. We're going to talk about what a relation is and also what a function is. So your objectives for today, we're going to graph relations, and then we're going to identify functions, and then also finish evaluating functions. A lot of the stuff in Module A you have learned from Algebra 1, but we're going to treat it like it's brand new for the most part, and we're going to walk you through everything along the way. Now, during my videos, if I say I need you to pause and work out an example, I really truly need you to do that because I want to see if you can understand and prove that you learned and mastered the concept that I need you to. So be honest with yourself, and I think these videos will be really, really helpful. So here we go. It says here you can use mappings to describe relationships between sets of numbers, and we're going to look at that when we look at different types of relations. So the essential understanding here says a pairing of items from two sets is special if each item from one set pairs exactly with one item from the second set. A relation, obviously that relation, it's bold and it's highlighted, so it's probably important. A relation here is a set of pairs of input and output values. You commonly know input and output values as x and y. And then we're going to talk about how you can represent a relation in 4 different ways. So when it comes to representing a relation, the first way is listing them as ordered pairs. So as we just talked about, your input and your output, or your x and your y, however you want to refer to those. And then you can see on the left-hand side here, they just have them listed as ordered pairs. This is probably the most common way that we see a relation, and it's really going to be prevalent as we go throughout Algebra 2. The second way is with a mapping diagram. We like to use mapping a lot because it avoids us from having to repeat values. And the really big difference here with mapping and let's say maybe a table is those arrows from the input to the output. So as you can see here, I have the point -3, 4. Well, what does that look like in the mapping diagram? The point -3, -4 is listed here with the arrow from -3 to 4. Same thing with 3, -1. You have your 3 as your input, and it's going to -1 as your output. Now with 4, you have 2 different y values. However, you only list the 4 one time. But you notice it has 2 arrows coming from that 4. So that's 2 separate points. You have the point 4, -1, and then you also have the point 4, 3. The big thing with mapping is you do not repeat values. Do not repeat values. Okay. Next way to look at a relation is via a table. So as you can see, they still it looks like mapping. They have the input and the output, but here they can have values repeat because they don't have arrows. And then the last way is via a graph. So you would just take those ordered pairs and just plot them on the graph. So 4 different ways: ordered pairs, mapping diagram, table of values, and a graph. So with problem number 1 here, we have a relation that is in ordered pairs. And we're going to talk about what this looks like in a table and mapping, and if we need to, we can graph as well. So if I'm going to create a mapping diagram, I'm going to have my inputs and my output. So for my input, I'm going to look at all the x's. Okay. So by looking at my x's, I can see that I have a 1 twice, but I'm only going to list it once. I have 2 and then 3. For my output, I'm going to look at my y values. And those are all different. And I'm going to put them in numerical order, 2, 3, 4, 5. So now the last thing I need to do here is draw my arrows. So I have the point 1, 4, so I'm going to go from 1 to 4. And then also notice back here you have the point 1, 5, so you're going to have to draw an arrow from 1 to 5. Then I have the point 2, 3, so 2 goes to 3. And then I also have the point 3, 2. Here is your mapping diagram. If you wanted to list those as a table, we could just do a little T-chart here, X, Y. We could say 1, 4, 2, 3, 3, 2, 1, 5. I'm running out of room to graph here, but so I'm going to try to use this graph up here so I can show you how to plot those points. So we have the point 1, 4, 2, 3, 3, 2, and 1, 5. So if you need to see those graphs, you can look up at the top in the orange. All right, so on this one, I want you to give it a shot. Try all of the different methods. They obviously have given the relation to us as ordered pairs. So if you would, go ahead and pause your video and go ahead and try creating the mapping diagram and the table of values. And if you want to, feeling pretty gutsy, go ahead and graph. When you are done working out your problem, go ahead and resume the video and you can watch me work it out to check your answer. This mapping diagram looks interesting here because you just had the same output value. So again, we don't repeat values here, so you only have to have the 3 for your outputs. But as you can see, all of my inputs went to that same value. If you were going to do a table of values, TOV, we can do our T-chart here. We would have 1, 3, 2, 3, 3, 3, and 4, 3. Now the graph of this is going to look pretty simple. But you could guess, if you have the same y value, it's going to be a straight line. If you have any questions over this, please make a note to yourself, like on your notes, so that way you know to come back and ask me when we have office hours, so you don't forget what your question was. But for now, we're going to go ahead and move on and talk about two other key definitions, the domain and the range. Y'all have heard this before. You should be able to associate what domain and range are, but we're going to go ahead and give you the definition here. The formal definition of domain is the set of inputs, also called the x-coordinates. And then you guessed it, the range is the set of outputs, also called the y-coordinates. So from problem number 1, they want us to go ahead and list the domain and range. Now, this is really important and it's really particular. Mathematicians want to be concise yet accurate. So here, we're going to just list what we see, okay? We're not going to create an inequality statement. You are literally just going to list the numbers in numerical order as you see them. So, for domain, we're going to use a D, and then a colon, and then a curly bracket, and I'm going to look at all of my x values and put them in order. Again, just like with mapping, do not put any values that repeat. So I know that 1 happened 2 times, but I only listed it the 1 time. Same thing goes with the range. If you have any values that repeat, only write them 1 time. I don't have any that repeat here, so I'm just going to list them in numerical order. 2, 3, 4, and 5. Again, rule of thumb. Do not come over here and say your domain was in between 2 to 5. I do not want an inequality statement. That's not entirely accurate, okay? And if you are interested in knowing why, we'll be more than happy to explain that to you. But all you have to do, keep it simple. Just list out the numbers that you see. Okay. All right. I thought I had a U-try problem, but if you want to, you could try with this one. We can totally try with this one. Let's do it. So let's come back to this last slide, and let's list out our domain and our range. So our domain would be 1, 2, 3, and 4. And our range, this would be easy because it's only one number. I don't have to list 3 that multiple times. I just have to list it one time. Okay. Now that we've gotten domain and range cleared up, let's talk about what's a function. Now, you can be a relation and not be a function, okay? There is a test whether a relation is a function or not, okay? So a function is a relation. That's key, okay? A function is a relation where each element of the domain corresponds with exactly one element of the range. Now, if you're me, you're like, what did you just say? Right? You're like, I can't decipher what that just told me. So let's break it down into easier terms for you, okay? A function is where no x values repeat, okay? A function is where you have no x values repeating. That is what that whole thing says. So here, let's look at problem number 3. It says, is the relation a function? Okay. Well, all I have to do here is look at the domain. Now, this is a mapping diagram. So I'm going to have to figure out, okay, are there multiple arrows coming from any of these x values? Right? So if I were to list these out as ordered pairs, I would say that's -3, -2, 0, 7, and then 4, 1. Do I have any x values that are repeating? No. So is the relation a function? Is this relation a function? Yes. Because no x values repeated. Okay. Same thing with B. We're given an ordered pair diagram. Let's look to see if any of our x values repeat. Do they? Right there. The 4 repeated. So is this a function? Nope. Because I had an x value repeat. On the next slide, go ahead and see if you can do A, B, and C on your own. So like I said, go ahead and pause the video. And if you want to go ahead and try these out on your own, please do. And then have something written down for C as well. This is kind of like a reasoning type question. Think about how you're going to answer C as well. So go ahead and pause, and I'm going to work these out, and then you can hit play. Okay. On A is not a function because you have 2 arrows coming from 2, so that means that the x value is repeated. Because if you listed those out in ordered pairs, you would have 2, -3, and then you would also have 2, 3. So those repeated. On B, you don't have any x values that repeated. So on C, it says, how does a mapping diagram of a relation that is not a function different from a mapping diagram of a function? And what I can see is if you have multiple arrows coming from a domain value, right? Just like on A here. We had multiple arrows coming from that 2, so that's how we know that this is not a function. You could have written something in your own words very similarly, and it would have been just fine. So we've looked at determining a function from ordered pairs, a mapping diagram, and essentially a table of values. Now, the last thing to determine whether a relation is a function is by looking at the graph. And we can use what we call the vertical line test. It says here you can use the vertical line test to determine whether a relation is a function. That's what I just said. The vertical line test states that if a vertical line passes through more than one point on the graph of a relation, then the relation is not a function. Well, clearly this relates back to what I just talked about. It's not a function if you have any x values that are repeating. So let's say on this graph, this is at like 3, right? You would have the point here, 3, 1, and you would have the point 3, 3. Well, your x value is just repeated, right? So the vertical line test isn't necessarily different. It's in conjunction with what we have said earlier. It's just a visual of what we said, okay? So the best vertical line that you have on you is your pencil. So if you ever want to take your pencil and just drag it across the graph, you can tell whether the function or the relation is a function or not. So we're going to do that right here. On problem number 4, it says use the vertical line test. Which graph represents a function? Well, on A, it hits in 2 places. So that's not a function. On B, does the vertical line test pass this equation? Yep, it sure does. And then on C, it's hitting in 2 places here, so that's not it. Our only answer here is B. Okay. So go ahead and try A, B, and C down at the bottom. Be sure to read the question carefully. Hit pause, answer them, and then once you have them answered, hit play and see if your answers match. On this one here, B and C would both represent functions because they pass the vertical line test. So if you take your pencil and drag it across from left to right, it does not hit any place more than once. All right. That is the end of the mapping and the relation part. I'm going to go ahead and pause this video, and I'll have y'all pick up with another one because the second half is a little bit longer. So if you need to take a break, please feel free to do so before you watch the second half. The second half will be coming up shortly.